Hello. In this video we're going to look at how we can use what we've learned about dilation, reflection and translation to sketch pretty much any graph. So any of those 8 standard shapes we should be able to sketch using DRT, and we have to include the 4 labels. These are very important. You pretty much always have to include them. I can't think of a circumstance where you wouldn't. The first one is axis intercepts. So this is where your graph hits the X or Y axis. You put those in. Next is endpoints. So this is particularly important if your graph has a restricted domain. You're likely to encounter endpoints. Then we have asymptotes. Make sure you don't touch them. Make sure you mark them clearly and label them. And turning points. So they get labeled with a coordinate. And I'm going to include points of inflection in that category, not to forget them. Okay, so we know what our 4 labels are. We know what DRT is. Let's use this to sketch some graphs. I'm going to look at an example of a square root graph. And we're going to see how we can use DRT to sketch this graph to help us. And we're also going to look at the 4 labels. Here we have y equals the square root of negative 4x plus 2. Alright, pretty unconventional already, so this is already getting fairly challenging. Thing is, if you're asked to sketch a graph and it doesn't ask you to list DRT, there are no marks for DRT. So you need to do DRT as quickly as possible with whatever notation suits you, whatever works for you. I'm going to do it here. So we have a 4 in front of the x, so I know that's dilation by a factor of, well, it's in front of the x there, so it's by a factor of a quarter, and that's from the y-axis. Notice how I'm using shorthand here. Reflection, yep, I can see reflection there. There's a negative sign, that means there's definitely reflection, and that's reflection in the y-axis. And translation, 2 up. I've just written T for translation, 2 units up. So we've got DRT. And then what I recommend you do is draw mini graphs. So just little sketches of how we get from the square root of x to this. Remembering that there are no marks for this, so be as chicken scratch as you can. So mini graphs. Well, the square root of x, I know, looks like that. Then we're going to have the dilation. So I'm just going to imagine the dilation happening from the y-axis because there's no kind of other curves to reference from. But if we wanted to put it in, let's just pretend we're doing, yep, we've got the dilation, so it's by a quarter from the y-axis. So it's going to be something like that. Reflection in the y-axis, well, that's the y-axis, and I'm going to reflect in it, so it's going to end up looking reflection in the y-axis like that. And then it's translated 2 units up. So it's going from there, it's going 2 units up like that, and the starting point's going to be something there. See how those little mini graphs help you make sure you've got the shape right. These are really useful tools. I didn't know this when I was going through methods. I had to have another person show me, and I think they're really fantastic. So after you've got that, you can see the features that you'll need to find. So already you know not to search for an x-intercept, because you can see on your mini graphs there's going to be no x-intercept. But we can definitely search for a y-intercept, and that y-intercept is going to be the endpoint as well. So of our 4 features, all we need to have is the y-intercept and the endpoint. There are no turning points, there are no asymptotes. So let's find those features. To find the y-intercept, we make x equals 0. So that means y equals the square root of -4 times 0 plus 2. Well, that's going to be 0, that's going to go, so then there's 2. So that point is 0, 2. As you would expect, you may have been able to determine that without doing this process. I like to do the process anyway. So with that information, we can now sketch the graph. Let's grab our ruler. I'm going to be really good and use a ruler. I'm going to draw my axis nice and big. No need for any of these little tiny graphs. Be generous with your axes because you want to show features. You want to show features on the graph. You want to show these clearly. So make your graphs nice and big. You want to show you know what you're talking about. Alright, well, this endpoint here is at 0, 2, so I'm going to say that's there. Always mark points with a cross to show them very clearly. But in fact, endpoints, you tend to mark them with a circle. I reckon you tend to mark them with a circle, yeah. In the case of endpoints, do a circle. Alright, and we know the shape. We know it looks something like this. Because we're good students, we're going to put another point on this graph to show the dilation. So to show the dilation from here to here, we're going to put a point that's kind of like a reference point. And in fact, that's not quite perfect. I'm going to do it again. That's a little better. Let's put a reference point in. So what's a value of x I can sub in there to get a nice y value? Let's try x equals -1. So let's let x equal -1. Well, y equals the square root of -4 times -1 plus 2. -4 times -1 is 4. Square root of 4 is 2. 2 plus 2 is 4. Alright, let's see. So when x equals -1, know that y equals 4. There we are. That is the graph of y equals square root of -4x plus 2. And we can see how useful DRT and the mini graphs were. They really showed us what was going on and they removed any kind of guessing games. Highly recommend you do that. Let's look at another example. This is going away now. And I'm gonna pick a different basic shape to start off with for each graph, just to show you how it applies to any. Let's do the absolute value graph. And if you're unsure what that is, refer to the first videos where we look at that. +1. Alright. First thing that should leap out at you is that coefficient of x isn't 1, it's 3. So we need to factorize. That's step 0 of DRT. We have to factorize like that. There we are. And there's a nice thing we can do with absolute values. Well, the absolute value of 3 is going to be 3 because it's already positive. So let's have it. Let's have that just leap out here and multiply with -2. So we've got -6 and then the absolute value of x minus 1 plus 1. There you are. You didn't get tripped up by these factors in here. We've taken out the 3 and put it out the front. Alright, now it's DRT time. Dilation by a factor of 6. And that's going to be a dilation by a factor of 6 from the x-axis. And then we have reflection. Well, yeah, there's a reflection in the x-axis because the negative's out the front there, so we get the reflection in the x-axis, that's right. Translation, 1 unit to the right and 1 unit up. So let's draw our mini graphs. Well, absolute value function looks something like that. And then we have a dilation by a factor of 6 from the x-axis. So we know what dilation does. It's going to be like that. Reflection in the x-axis. Just like that. And we're translating 1 unit to the right and 1 unit up. So we're going to go 1 unit to the right and 1 unit up. So we're not quite sure yet. We don't know. This might pass through the origin. It might pass through there, or it might pass down there. We don't know yet, but we can find out by finding the x and y intercepts. That point there, we should find the coordinates of that vertex as well. It's kind of like a corner. Think of it as like a turning point, but not really. Let's do that then. So x-intercept, make y equals 0. Well, 0 equals -6, the absolute value of x minus 1 plus 1, minus 1 from both sides. And then we're going to divide by -6, so we get a 6 equals the absolute value of x minus 1. Alright, so with absolute values, we have to check something. It's kind of saying two things here. There's two equations that could be possible here. There could be this is overall negative, or this is overall positive. So I'll show you how to break this up. So we know that it's either a 6th equals x minus 1, or a 6th equals negative x minus 1. Because the absolute value of both of these is x minus 1. So we have to solve each one individually. Let's do that. So add 1 to both sides, x equals 7/6, or we've got a -6 equals x minus 1, add 1, x equals 5/6. So here we are, we've got our two x values, so we know they're both positive, so we know that the graph here is going to go like that. They're going to be positive x-intercepts there and there. That means the y-intercept is going to be negative. Let's find the y-intercept. Make x equals 0, so we have y equals -6, absolute value of -1 plus 1. Absolute value of -1 is 1, times -6 is -6, plus 1 is -5, just as we expected. So we have 0, -5, 7/6, 0, 5/6, 0. Alright, we've got all the information we need to sketch this graph. We know what its shape is going to be, we know the x-intercepts, and we know the y-intercept. The question is how we're going to find that vertex. And the trick to that is it's going to occur halfway between these two values. Kind of like a parabola with its turning point, this vertex is going to happen halfway between these. So we can take the average of these 2 points, that could be one way. Another way could be to apply transformations to 0, 0. So we can see, well, it starts at 0, 0, and it goes 1 to the right and 1 up. So that means, well, 0, 0, if it goes 1 right and 1 up, you know that it's going to be at 1, 1. So there's a couple ways to do that. It's up to you. So here I've said, well, that's the origin. It's going to move 1 to the right and 1 up. So I expect it to be 1, 1. sorry, no, that's just the x value. So I expect the x value to be 1. So let's do it by finding an average of these two. Let's see, 5/6 plus 7/6 equals, well, we're going to divide it by 2 for an average, equals 12/6 on 2. 12/6 is 2. 2 divided by 2 is 1. So that gives us 1. So that's right, we do know that that's going to be at 1. Let's sub it in to find the y value. So y equals -6. 1 minus 1 plus 1. So that's 0. So yes, we do get 1, 1. Okay, couple ways to think about it. One way is to go through the transformations. Another way is to solve by finding the average of these two. I reckon the transformations are easier. I like to check it a couple ways. Alright, well, we've got all our features. Now we can sketch the graph. So let's do that. I'm going to clear that. So we need to find our ruler. There's our ruler. Pop that one over there. Nice and big. No reason to make anything small with graphs. Show you know what you're talking about. There we are. Get rid of the ruler. Alright, and of course I should use a ruler as well to do the actual graph. Should practice what I preach. Let's put that there, and then it's going to turn around like that at that point, and it's going to go like that. Alright, now we get to label all the points. So we said that this one was 5/6, 0. This one is 7/6, 0. This was 0. What was that? Just remembering. 0, -5. And this one was 1, 1. And let's label our curve. Alright, there you are. So we've used DRT and mini graphs and found x and y intercepts to sketch these graphs. I want to do a couple more examples, but I'm going to do that in another video. So in the next video, I'll do exactly what's done here. I'll do a log graph and I'll do an exponential graph just to make sure we're clear on what needs to happen. And if you have been, thanks for watching.